Okay, so previously we talked about drawing the Lewis structure or the electron dot diagrams for neutral atoms or single ions. Now we're going to look at how we're going to draw those same structures for polyatomic ions. Now, poly means more than one, so what we're talking about is an ion that's a compound, and we have more than one different type of atom. For example, NH4. NH4 is an ion with a positive 1 charge, and it consists of 1 atom of nitrogen and 4 hydrogen atoms. Okay? First thing that we're going to do is we're going to count the number of valence electrons. Okay? So, in nitrogen, we know that from looking at the periodic table, it has 5 valence electrons. And then hydrogen has 1, but we have 4 hydrogen atoms in NH4. So that's going to give us 4 valence electrons coming from the hydrogen. Okay? But we know that we're talking about a cation. Okay? That means that it lost an electron. So we're going to subtract 1 too. That's going to give us 8 electrons. Okay? Total of 8 electrons. All right, step 2. We're going to draw the skeletal structure. Okay? We're going to start by using the atom, the element, that has the least electronegativity. In this case, it's nitrogen. Okay? Hint, hydrogen will never be the central atom, and this is because it only has 1 electron. It can only bond to 1 atom. So it'll never be the center. If more than 1 carbon atom is present, they will be attached in the center. We'll get to carbon later, okay? So we're going to start with the structure by bonding our central atom to 4 hydrogen atoms, okay? Each one of these dashes is going to represent 2 electrons, okay? So right off the bat, we've got 1, 2, 3, 4, 5, 6, 7, 8. Well, that makes the next step really easy. We can rewrite that just like this. All right. Now remember, the goal for these atoms when bonding is to become a noble gas. Okay. So that would mean that they would have a full outer shell. In each of these cases, for hydrogen and nitrogen, we did that. Okay. Hydrogen now has 2 valence electrons in its outer shell, completing it, making it equivalent to helium, a noble gas. Nitrogen did the same thing. Now it has 1, 2, 3, 4, 5, 6, 7, 8. So it's full and happy, and we have a stable compound. Okay? So step 3 was to add the dots, and in this case, we replaced those dashes with 2 dots apiece. Count the dots to see if they match the number of electrons needed. Okay? And we just did that. But now we're going to, since this is an ion, add brackets and record the charge. All right? And so that shows NH4 as a plus 1 cation. Okay? So let's do one more example here. Write the structure of bromide. Let's do that one. So I'm just going to write BrO3 -1. Okay. So we're going to start by counting the atoms. How many does bromine have? Well, it's in the 17th group, so it's going to have 7. 7. And oxygen is going to have, it's in the 16th group, so it's going to have 6. But there's 3 oxygen atoms in one compound. So we're going to go 6 times 3. And then we're going to have a -1 charge overall. So that means we're going to have to add an electron. Okay? So that gives us 7 plus 18 plus 1. That is equal to 26 electrons. All right, so now we know we need to plot 26 electrons in this compound. All right, let's start by putting the least electronegative atom in the center. That's going to be bromine. Okay, now let's bond it to the 3 oxygen atoms. All right. Now, remember, each of these dashes represents 2 electrons. Okay, oxygen and bromine are sharing 2 electrons to bond. So we go from 26 to 20. Now we need to plot 20 more electrons in this diagram. Okay, so what we could do is take 20 and divide it by 3. 1, 2, 3. We need to plot electrons on those oxygen. So that leaves us with 6 apiece and then 2 to spare, right? 20 divided by 3. Let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? So what we see here is each oxygen atom in this compound so far has a full outer shell of 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Bromine, on the other hand, has 1, 2, 3, 4, 5, 6. But we still have 2 to plot. So let's do so. Okay? Now you can see that the bromine and the oxygen atoms in this ionic compound are all full and happy. Okay? So last thing we got to do, bracket, -1 charge.